In this video, we're going to talk about graphing logarithmic functions. We're going to do that with transformations, just like we have done with the other types of graphs. This is the parent graph over here for a logarithmic function. It's going to have a vertical asymptote at x equals 0. It's going to have a characteristic point here at 1, 0. It is going to have a domain of 0 to infinity, and it's going to have a range of negative infinity to infinity. So let's see, its characteristic point is going to be also going to be at a1, be another characteristic point. So let's go ahead and see here that this one has not been shifted up, down, left, right at all. So we can just go ahead and put a is 4 in here. And there's our graph. It's going to go through 1, 0, and it's going to go through 4, 1, is right there. Those are the characteristic points, and it's going to have its vertical asymptote at x is equal to 0. This one's going to have a vertical asymptote at x equals 0. It's got a domain of 0 to infinity. It's got a range of negative infinity to infinity. It's got characteristic points at 1, 0, and 1/2, 1. The logarithmic function is going to be the slowest growing function that you know about right now. The exponential function that we talked about a couple videos ago is the fastest growing function that you're going to know about right now. 1, 0, and 1/2, 1. So this one is going to come this way. And so like that. Now if I have 3 ln of x, this will be ln of x, and the y value is going to be multiplied by 3. I'm still going to have 1, 0, but at e, which is 2.7 something or other, instead of 1, I'm going to have 3. And so I've got my vertical asymptote at x equals 0 again, and this is going to be stretched like so, but then it's going to start leveling out. So I'm going to let my base here be e, and I'm going to have 3 times, and take a look at how that's like what I have there. Now I've got -2 minus ln of x, so I want a negative. Got my base is e still, and I want my k to be a -2, like so. The domain here was 0 to infinity. My range was negative infinity to infinity. My characteristic points were 1, 0, and e3. So right here, the domain is negative infinity, or is going to be 0 to infinity. My range is going to be negative infinity to infinity. My characteristic points are going to be at 1, -2, and e, -3. And 1, -2, e, -3, vertical asymptote here, and it's going to come up here like so, and it quickly levels off. Doesn't go quite to level, but it's going to just decrease very slowly, right? Domain here, it's going to be -4 to infinity. I got that -4 by setting this x plus 4 that's inside the log to 0 and solving. My range is going to be negative infinity to infinity. And let's see what happens here when I have a negative ln of x plus 4. Like that. And then plus 2. Like that. My graph is going to look like so. I've got my vertical asymptote at x equals a -4. X equals -4 is my vertical asymptote. At -3, I'm going to get 0 plus 2 is 2. At be hard to graph, but it's going to go through here at 0.6, so on. It's right about there. So there we go. Across the x-axis at 3.389. So coming like so, and going down like that. All right, just a couple more. So we're going to use transformations of log base 4. Of x. And we want x plus 1, so we want a -1 on the inside. We don't want any vertical shift, so it's going to look like so. We have vertical asymptote at -1. And sorry, no negative there. And we're going to go through the point 0, 0. We're going to go through the point 3, 1. We're going to go through the point that's it. That's the only point I can go through. So it's going to level off like that. And log base 5 of x. And we want to have no horizontal shift, but we want a vertical shift of -1, like so. And it's going to give us a x-intercept at 5, 0 over there. When x is 5, log base 5 of 5 is 1, 1 minus 1 is 0. That's where that came from. Log base 5 of 1 is 0, 0 minus 1 is negative 1. There's going to be a vertical asymptote at x equals 0. And there's just a very slow growing logarithmic function right there. Now we want log base 2 of x, and we want 2 times that with no vertical shift and no horizontal shift. Log base 2 of 1 is 0, 2 times 0 is 0, so there's a 0.10. Log base 2 of 2 is 1. 1 times 2 is 2. Log base 2 of 4 is 2. 2 times 2 is 4. And we're going like this. It's an asymptote right here. And so on. Last one for this video before we come back and solve some logarithmic equations next time. We're going to use a base of 4. And we have a multiplier of negative 1/3. No vertical shift. Log base 4 of 1 is 0. We have a 1, 0 still. Log base 4 of 4 is 1. 1 times negative 1/3 is a negative 1/3 down there. We have our vertical asymptote here at x equals 0. We have a function that is going to go like so. All right, that's it for this video. Come back next time, like I said, and talk about solving logarithmic equations using exponential forms, rewriting them, or using our calculator to approximate them with exponential functions. See you next time.